500 years ago, we thought we knew that the Earth was the center of the universe. But now we understand that it orbits the Sun, and the Sun is at the center of the next level of reality, the solar system. It's a fairly ordinary star, and it shines because at its center, hydrogen atoms are squeezed so tightly they fuse together, forming helium and giving off massive amounts of energy in the process. That energy, radiation traveling at the speed of light, takes about 8 minutes to reach the Earth. But the radiation has to get from the Sun's core, where it's created, to the surface of the Sun, bouncing off the squeezed atoms as it does so. The atoms in the Sun are so tightly packed that a journey that should take 2 seconds in a straight line actually takes 10 million years. So the heat and light that fuels life on Earth today was created long before humanity even evolved. The Sun heats and lights the whole solar system, but just as important, it holds the whole system in place. Isaac Newton published his theory of gravity in 1687. And his calculations showed how gravity keeps the planets in their orbits. It seemed the universe was a place of mechanical precision, and using Newton's mathematics, the rising and setting of the Sun and the phases of the Moon could all be predicted. This same mathematics allowed us to calculate the path of space probes. In the past, all we could do was to point telescopes at the sky, but now we can send probes to visit the planets close up. Mercury is so near the Sun, it's rarely seen with the naked eye. In 1975, the Mariner probe showed us that Mercury is a dead, small world that rotates so slowly that its day is longer than its year. During its day, temperatures reach 660 degrees Fahrenheit, hotter than an oven, and at night, less than negative 275 degrees. The next planet out from the Sun is Venus, the evening or morning star. But although it shines so brightly in the night sky, the planet itself is hidden by clouds. The Magellan probe used radar to see through the clouds and found a turbulent world. The greenhouse effect of the cloud cover keeps the surface at 842 degrees, hotter than Mercury and hot enough to melt lead. And then, the third planet, home. At this scale, the Earth is unique. It's a double planet. Its moon was once a part of the Earth itself, smashed off by an impact with a lump of rock the size of another planet. The next planet from the Sun is the stuff of science fiction, Mars. But the Mariner probe showed there were no Martians, no water, and little atmosphere. But the surface is spectacular, covered in deep gashes, including a Grand Canyon the length of the entire United States. There are also the remains of huge volcanoes, one rising 15.5 miles above the surface, the biggest volcano in the solar system. Perhaps the most famous probes are the Voyager spacecrafts, launched in 1977 towards Jupiter, the giant gas planet. so big it could swallow the rest of the planets with room to spare. It's a swirling, seething ball of gas, including methane and ammonia. Storms rage over its surface. Hurricanes far more powerful than any on Earth. Beyond Jupiter, Voyager journeyed on to another gas giant, Saturn, with its famous rings. The rings aren't solid. They're made of tiny fragments of ice and rock, possibly the remains of a shattered moon or comets. Beyond Saturn is Uranus, an ice giant. Uranus has a very strange movement. It rolls around the sun on its side, its moons circling it like a giant Ferris wheel. So far out that the sun is just a distant point of light. Neptune's orbit is so vast that a year on Neptune takes 165 Earth years, 2 human lifespans. Neptune is another ice giant like Uranus, but we know little more about it. But Newton's mathematics showed that between the orbits of Mars and Jupiter, there should be another planet. There isn't. Instead, there's a band of millions of lumps of rock, the asteroid belt. We have no idea how many asteroids there are, but they range in size from small moons to house bricks. And at this level, the precise mathematics breaks down, and chaos appears again. For the motion of the planets, Newton's laws are only approximations. Even the equations for just 3 bodies of similar size are hideously complicated, beyond the reach of conventional mathematics. So it's completely impossible to predict what will happen in the asteroid belt.